the correct way and a cool, quick, and dirty way. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to show you how to use a steady rest. It's somewhat of an intimidating tool if you're new to machining, but it's a very important tool here in the hobby shop where rigidity is always at a premium. I'm going to show you how to use it right now. Making your way in the world today takes everything you've got. Taking a break from all your worries sure would help a lot. Now normally when you're working with long stock you want to work as close to the chuck as you can. However, the diameter of your stock might be too big to go through your spindle bore, but you still need to be able to make features out near the end. Now perhaps the middle area of the stock can't be gripped in the chuck, maybe there's finished surfaces or other things that prevent you from doing that. So how can we make a feature way out here on the end? We're way out here in the land of zero rigidity in the capitalist Chattertown.
Who runs Chattertown?
Enter the steady rest. What the steady rest does is allows you to create a zone of rigidity far away from the chuck. In fact, you can create rigidity anywhere you need to along the ways. So make sure we don't have any chips in the area where we're going to set it down. Now the basic premise is very simple. The steady rest sits on your ways and it has some form of support system here in the center that can ride on your work. Now it might be rollers, as you see here, or it might be brass or bronze fingers of some sort. Neither of these two options are better or worse. I think it's mostly preference. Personally, I like the rollers. I find it easier to control the tension on the arms with rollers. A lot of people prefer brass or bronze fingers. The common argument in favor of these guys is that they don't tend to get chips under them as much as the rollers sometimes do. So, whatever takes your fancy, but they both work the same way and setup is basically the same. Now the trick is though, you have to have a machined area on the part for the steady rest fingers to ride on. And that's because of course this part is spinning and the fingers are rigid, so that means the surface upon which the rollers or fingers are riding has to be running concentric to the axis of the lathe. So that feels like a chicken and egg problem, right? The whole reason we're using the steady rest is because we want to do some machining way out here. But now you're telling me I have to machine something way out here in order to set up the steady rest. How do we resolve that? Well, the basic setup order is you put a center in the end of your part, and then you support that part with a center in the tailstock, and then you can machine an area for the steady rest to run on, and then you can remove the tail support, install your steady rest, and do your work out here. So step one is you got to get a center in the end of your part. Okay, but that seems like another chicken and egg problem, right? How can I put a center way out here where there's, again, no support? There's a couple of different ways to do that. The first approach is the simplest. Just go ahead and put your center in it with all of this stick out. Center drilling has very low lateral tool pressure compared to turning and other operations, so you can get away with doing it with way more stick out than you could any other type of operation. And the center doesn't necessarily have to be very good because we're only going to be using it briefly and we only need to take a light cut to get a machined area for the steady rest. So you could, for example, put in a much smaller center than you would normally use for stock of a particular diameter to minimize the cutting forces. But wait a minute, you might be thinking. The whole reason I want the steady rest is because I don't want to put a center in the end of my part. I need to work on this end and I need the end to be pristine, and so I can't use regular tail support. Well, an easy workaround for that is just to leave your stock long, and then after you were done with the center, we got the steady rest set up, then you can just machine off the end. And it'll be like the center was never there. However, there are times when this setup won't work for putting a center in your part because maybe the stock is really long and you don't have the rigidity for even a center drill, or if the material is thin, it might be drooping. So then if you try to put a center in that, your center is not going to end up in the center of the stock because the stock down here is sagging. The other extreme use case is if your stock is longer than you have space for between centers on your lathe. If you're working right at the limit of your bed, you can remove the tailstock and get some extra length to work on longer parts than you otherwise could. However, of course, if you do that, that means there's no way to put a center in it with your tailstock because, well, the tailstock is on break. In cases like that, we can go old school. Now again, the point is we just have to get a center in here any way that we can. It doesn't have to be a great one because we can actually recut it once the steady rest is set up. So when all else fails, here's a method to get a center in there, and that's with old-fashioned layout. So we'll glue up the end of our stock here. And then you can break out this tool. This is a center finder. Now there are other methods for finding the center of stock using layout, but This is a great tool that makes the job super easy. So all we have to do is line that guy up on there, like so, and then scribe a line, and then rotate it, let's say 90 degrees, scribe a line. And it's a good idea to do a couple other angles as well. And now, generally, those lines are all going to intersect basically at one point. If there's any kind of a little triangle in there, it might be because your stock isn't very round, hasn't been machined yet, so who knows how round it really is. But the center of whatever little triangle might be there is going to be very close to the true center of your stock. And just like any other hole-making operation involving layout, you're going to find the center of those lines and center punch it, like so. And as I've shown in previous videos, if you need to move that center punch, if you missed a little bit, you can center punch it at an angle to shift the punch and then repunch it vertically once you're happy with the location. Now, how do we actually drill that center if we can't do it on the lathe? Depending on the length of your stock, you might be able to do it here on the drill press. A good trick is to simply swing your table to the side, and you can clamp your material to the side of the table, and you can get a lot of length that way, especially if it's a floor standing drill press. You probably won't have room to do this in your mill. If you don't have room in your lathe, you almost certainly don't have room to do it in your mill. But yeah, the table trick here on the drill press, or failing all of that, you can also just put a center drill in your hand drill and do your best to get it straight. Again, the center doesn't have to be great, only has to be used for one light cut on the steady rest area, and then after that you can recut the center if you need it, or you're going to be cutting it off anyway. The point is, get a center drill in there by any means necessary and move on to the next step. But in this case, I think we can get away with just cutting the center with the stick out that we have. Go, go, gadget, tail support. Oh, right, we used up our special effects budget in the last video. All right. Now we can machine an area here wide enough for the rollers or fingers on our steady rest. Now plan this carefully because the steady rest can take up a fair amount of room, and you need room to get the tool post in around the steady rest, and you might need room out here for, facing off the center if you don't want the center in your final piece. And so you probably need more space here than you think you do, so you only get one shot at this, so plan ahead. I'm using a sharp nose tool here since we're plunging directly into the work to create a little surface. It's not something you generally want to do, so our surface finish won't be great, but that's okay, the steady rest isn't paid enough to care. This bar has a pretty impressive bend in it. I had to cut about 40 thou there to get a concentric area, but that's actually going to exaggerate the effects of the steady rest out here, which is definitely something I did on purpose to help you with the learning. Now we can bring in the steady rest. Make sure you get your carriage on the correct side of it, depending on which area you're going to be machining. That's definitely not something I've ever done wrong. You want to make sure that the ways are clean. You don't want any chips underneath the steady rest that might affect the rigidity of the setup or damage any of the surfaces. Make sure the bottom of your steady rest is clean as well. In we go. We start by clamping the base, of course. Tighten that to the German standard, Guten tight. Now comes the real art of the steady rest setup, and that's seating the fingers or rollers on the work. There's two schools of thought on this. A lot of the books, especially the older books, will tell you to use a 1 thou feeler gauge in there, like so. The idea being that gives you just enough clearance for an oil film in here for the fingers or rollers to ride on. And the second school of thought says you just do it by feel. I've tried the feeler gauge method. I haven't had a lot of good luck with it, so I just bring the fingers in until they're very, very lightly touching. And then if I am getting chatter, then I just snug them up a hair more until the chatter goes away, and that seems to work for me. New in the Blondihacks store, stainless steel insulated beverage tooling. Extremely repeatable, compatible with metric and imperial beverages. Also good for storing cutting oil. And like any other sliding mechanism in machining, these fingers will have a lock on them, so once you get the feel just right, then of course you're going to want to lock them down. And then we want to get some oil on that surface. Whey oil works fine. And you might think you don't need it if you're using rollers, but it is still actually recommended. There we go. And as you're working, keep an eye on that area. Don't let it get dry. A quick safety note, when you're working around a steady rest, keep your hot dogs extremely well clear of this area. This right here is a real meat grinder. Anytime you've got two spinning things doing this, or even a spinny thing and a stationary thing in the case of a finger, suffice it to say, anything you get in there is going to cease to exist very, very fast. Arguably, this area here is even more dangerous than the chuck. The chuck is going to smack your finger and break it. This is going to make your finger no longer exist. For most common steady rest setups, we're done. Power up the lathe slowly, make sure everything looks okay, and then now you can bring it up to speed and start your machining. However, there's one little gotcha here. Think about what this steady rest is doing. It's supporting the work from the outer diameter. So it's creating an axis of concentricity. But so is the chuck. Now, I did a whole video on concentricity, and one of the key elements of that was that the chuck, especially the three-jaw chuck, is creating an arbitrary axis of concentricity from how the chuck jaws are interacting with this surface. This arbitrary relationship here is establishing the center axis of this part. But now we've got the steady rest down here trying to do the same thing. We've got two competing arbitrary axes of rotation. Round one, fight! Now, if you're careful with how you apply the fingers, the axis that you create out here is going to be very, very close to the true one back here, probably so close that it'll be sufficient for any part that you're making. However, if you are, for example, working on the end of an already machined shaft, and so this area here all has a specific axis of concentricity that needs to be maintained out here, then you might need to get more serious. If you need to be certain that this axis of concentricity is as close to this one as you can possibly get it, then we can verify with the dial indicator that we haven't introduced any deflection in the part between here and here. So we bring in the dial indicator, and this can be a little tricky to get around the steady rest, but it's important that the base of this guy be on your cross slide. You want it to be pretty vertical. We'll just give ourselves a 0 here. Now, if this axis is the same as this axis, then as we slide this indicator back and forth, it shouldn't move. Now you can see that we've got about 5/1000ths of difference there. Now, this, however, is an unmachined surface, and recall that this bar actually has a bend in it as well. So this test is really only valid if you have a machined surface that has been set up probably in a 4-jaw chuck or between centers so that you know it's concentric with the lathe down here. So I show you this for demonstration purposes only. You really can't do this test on an unmachined surface of unknown concentricity to the lathe. In any case, once you've got that top reading, then you do the same reading on the side. So I'll do the back here because it's easier to set up. But you can do it on the front as well. And then I'll use the cross slide to preload that. And then do the same test back and forth. So in this case, we've got, again, about 5/1000ths there. But if this was a machined surface that we knew was concentric to the lathe, then we would want to see 0 there. And what you would do is you would adjust your fingers until both of those readings at 90 degrees apart are at 0, and then you can be confident you haven't altered the axis of rotation out here. But for an unmachined surface like this, it doesn't matter because when you go to machine this, then you will be creating the concentricity. And that's part of why it doesn't actually matter a whole lot if there's a lot of run out here, because if this is the first machining operation that you're doing on the part, as it often will be, then this out here is now your concentric reference. So it doesn't actually matter where the steady rest lands as far as creating an axis of concentricity, as long as your subsequent setups then reference this surface and this axis, then everything will remain concentric. Okay, let's make some chips here. Now you can see how much run out there is in that bar due to the bend. You can really see here how the steady rest is creating rigidity and concentricity. We can do roughing passes and finishing passes, all just as though we were working right close to the chuck. Let's talk about operations on this end now. There's generally two cases. Either you want this end faced, which is part of why you're using the steady rest. You don't want that center in there, in which case that's easy. You just face the end off right now, and That's the nice thing about the steady rest, is that we can face this part off and do operations way out here, far away from the chuck. Or you might want to keep that center for subsequent operations. Maybe you're going to do another step where you turn between centers, or maybe you're going to use that as a reference for some future operation. Now recall that when we made this center, we may have done strange and heroic things to get it in there. We may have used a hand drill, or we may have used a janky setup on the drill press just so that we could get a center in there long enough to machine this area for the steady rest. So this center may not be a very good one. Now is our chance to recut that center and do it properly. And the important thing is that because the axis of concentricity right now on this end is being established by this relationship between these steady rest fingers and this surface that we machined, if we recut that center now, that center will be concentric with the running area of the steady rest. So this becomes a pair of valid reference surfaces and a valid reference center. There's two ways that I know of to recut a center: the correct way and a cool, quick, and dirty way. The officially correct way to do it is to treat that center as a little tiny taper and recut that taper with your compound. If, like a lot of us, you tend to leave your compound set at 30 degrees for single point thread cutting, then this setup is already done. So all you need to do is turn your tool post such that you're going to be lined up for cutting inside of that tiny little taper there. Now, if you're going to attempt this, make sure you've got the right tool ground for the job. You're going to need a very sharp point on there, and you're going to need probably an exaggerated clearance underneath the cutting edge in order to not rub on any side of that tiny little 60-degree cone in there. But you can see how now, if I move my compound back and forth, how I would be describing the angle of that taper. And then if the work was spinning, you can see that I could now recut that taper. So this is very precise and very rigid, and this is a single point cut. So I'm just going to be skimming that. You probably only need a few thousandths to recut that taper to be truly concentric with where the work is now presently spinning. And this technique is not just for the steady rest. Anytime you need to recut a center, you can do this. So if you're repairing an old piece of equipment, let's say, and maybe you've got a shaft with a beat up old center that some grease monkey hammered on, you can set it up in a steady rest, get yourself a nice axis of rotation, and then clean up the center with this trick. Question you might be asking yourself is, well, why can't I just go in here again with the center drill? Won't that just recut it? And the answer is no. The reason that doesn't work is because while the tailstock and the center drill are both quite rigid, they're not that rigid. And what's going to happen is that center drill is just going to deflect its way right back into the previously drilled center. And if you try this, you'll see that the center drill is bobbing up and down slightly as you drill. And what's happening there is the center drill is just following the unconcentric original hole and not really cutting a new one. Even if you try to go in with a larger center drill, that original hole is going to act as a pilot, and it's going to force the new center drill to ride off center. And that's why single point cutting a new taper in there is technically the correct way to do that, because just like turning an unmachined surface, a single point tool can create a concentric surface from a non-concentric one in a way that any kind of drilling or hole making tool can't. Okay, but obviously I'm not going to recut this the correct way, or I would have shown you that by now, right? So what's the quick and dirty way that also works pretty well? I got to credit Adam Booth for showing me this one. This is an awesome little trick. What you do is you orient your center drill so that the cutting flutes are horizontal, like so. So there's two cutting flutes on the center drill. One is back here facing down, and one is at the front facing up. And then we bring the center drill into the hole just like that. And then we bring the tool post in here, and then check and make sure the boss isn't looking. And then what we're going to do is, as we feed this in, we're going to put some light pressure on the quill with the tool post. And what that's going to do is push the rear cutting edge against the back of the little taper in there, and it's going to prevent the off-center hole from influencing the center drill. Any attempt by that hole to push the center drill off-center is just going to push it into the tool post. So just putting a little bit of sideways preload on the quill will create a hole that is concentric. And just like that, we've got a recut center that is perfectly concentric with this surface right here. Now all of this has been assuming round stock, which is generally what you're going to be using the steady rest with, but occasionally you might need to do some of these tricks with square bar or hex bar or perhaps odd shaped stock. You might have a casting or something like that that you need to run in the steady rest. For that we have this tool right here, which is called a cat's head. And what you can do is slide this guy onto the work, clamp it on there, dial it in to run true, adjusting the set screws, and then set the steady rest to the outer surface of the cat's head. And that will allow you to run virtually any shape or size of stock inside a steady rest. I did a whole video about making and using a cat's head. I'll put a card up in the corner there for that video. And that's the basics of using a steady rest. If you're in the market for a lathe, do make sure that it comes with one of these or you know where to get one, because it is a very, very important tool for working with longer parts, especially here in the hobby shop where we're working with frequently very thin stock and we're working with a lot of softer materials, and rigidity is always at a premium in the hobby shop. So steady rest is your friend. Don't be afraid of it. I hope I've shown you how easy it is to set up and use, and it will greatly expand the range of things that you can do on your lathe. Thank you very much for watching. I hope you found this useful. Throw me a couple bucks on Patreon if you wouldn't mind. The patrons are what keep the lights on my little channel, and we'll see you next time.